So just speak up if you have any questions, please. And this will be quite fast. This is not a very big section, because yeah, it's the end of my section. We don't really have time for a lot of practical, so I kept it relatively short. So this all links to I see there's still comments from my previous things that were on these slides, because I used the template. But in any case, this all links very much to data warehouses. This is and data warehouse, a place where it's more than one source. It's focused on decision support. There's reporting and analysis, centralized storage, etc. So you can see all these definitions. They focus very much on central storage and decision support. So here is also a very nice, out of a couple of sources, I made this table, and I thought it was quite interesting. So when we speak about database, your transactional databases, it's more about the real-time data. So when I make a purchase, it stores that information, deducts something from my account, etc. But then in the data warehouse, it has all the information about what I purchased, etc. So there's apparently this classic example of people wondering, bears and babies. You can look it up, but they said that fathers, young fathers, when they had to go and buy nappies, they never bought beer as well. So then they used the data warehouse to kind of figure out why this happened. So that was quite interesting. So in the data warehouse, it's more about historic data, where we try and analyze the data to answer some of our questions. So benefit of the data warehouse: decision making, consolidating sources, data quality, this is important, consistency and accuracy, and then using the history to make informed decisions, basically. Okay, so makes it possible to extract, archive operational data, legacy formats, etc. But this is where it starts being more relevant. So there's a pre-processing part when we talk about the architecture, which is where the data is transformed into a format that can work with the schema in our data warehouse. This is, for example, where you put your data first in. So in Amazon S3, you'll see in the assignment, I suppose, there's a link to that, where you first store your information. That gets then transformed and it moves to the staging. This is now where we fix things, naming conventions, styles, etc. So basically transforming the data so that it fits into our schema in the data warehouse, which is the master. Hold on. Let me just fix this. Hold on. So in the master, this is now where everything is standardized. Your data is basically ready to be used. There's no more fixing of the data now, just when we start using the data. And then the last part is the reporting. So this is where we expose the data so that we can pull tables out, say automized reports. You can also create a data mart from that. So this is a smaller data warehouse that's maybe focused only on a specific type of data. I just want to take a quick breath and get water. Okay, so this is now where ETL comes in. So extract, transform, and load. So this is a fundamental operation or component of a data warehouse, because we first need to, as you saw with the pre-processing and the staging, we need this process of transforming our data so that it works in our data warehouse. So this happens in the staging area. So basic categories is data extraction, cleaning, transformation, loading. I read this up a couple of places, and I do think it's something that I've spoken to you about before. You cannot start building a comprehensive solution if you don't understand the problem. So it comes down to the whole thing we spoke about in your third year as well, about business requirements. You first need to know what is it that you want before you start doing these processes. Because once you've changed the data, deleted things, change things, it's not always that easy to go back. So it is something that where you planning is quite important. So this is a nice example that I found. So we see the extract, we have various data sources, and we basically want to load this all into our data warehouse. But now the problem is there's some differences in our schemas. So I have male, female, for example, MF, male, female, 1, 2. But then in our data warehouse, we want male, female written out. So how do we actually get this? So in the transform section, we need to now basically map these values. So M becomes male, F becomes female. The HR data doesn't change. Online, it changes as follows. But you also need to clean the data. So this is now, if there's blanks, what do you do with that? Do we leave it blank? If someone writes null instead of male, what happens? Do you autocorrect it, etc.? So you also need to make sure that you fix those small things. Okay, so extract. This is the process to get the data from the original source. We don't change the data at this stage. We just extract it into our pre-processing phase, basically. This depends on the specific requirements. Limited data sets is a quicker ingestion. This makes sense because the less data you're pulling out, the faster it will be. So that's why you would do it probably incrementally. Have triggers that say once there's 1 million new records, we do this, etc. So there's various ways that you can start this process. Okay, transform, cleaning, integration, and enrichment. So I think those three make sense. And then loading. So this is the change data that's now loaded into our warehouse. But there's also a different, so we spoke now about ETL, but you also get ELT. So this change in just the one letter is actually not as simple as it sounds. So ELT is actually used a lot with big data. So the source is with ETL, we get some of the data, but with this extract, load, transform, we try to get everything. We are not as picky. So where requirements were very important when we spoke about ETL, with ELT, it's not that important because we want everything and we'll sort it out later. So streaming becomes also quite important there, and there's a lot of streaming options these days with Apache and Amazon and even Google, etc. There's a lot of streaming, data streaming services. Then data cleaning. So with this one, we do the data cleaning in the transform part. So we want to fix everything before we load it into our data warehouse. Whereas in
Sorry,
ELT, yes.
Ma'am, is a ELT basically used with the big data purely because you don't know what you want to do with the data as of yet? So you load it in first and then have a look at what you can do to transform it?
Not necessarily. Everything you said was fine except the last bit. It's not necessarily how you can transform it. So it works more on the concept of we just take everything because there might be something interesting. Where with the traditional ETL, we know what questions we want to answer. With the big
Okay.
data, we don't yet know. So we want to start looking at things that might be interesting, and then we'll go in and look at cleaning, etc., to see, oh, is this actually true, this thing that we found?
Okay, that
That
makes
makes
sense.
sense.
Thank you. Yeah, thank you.
Okay. Okay. So yes, as you can see, data cleaning, standardization is all deferred. So we leave it for later. Once we see that something might be useful, then we'll only start cleaning it. Okay. and as we said, used for big data. So extract, same type of process. We don't need requirements as we said, so it's not so specific. Again, loading, so no cleaning, etc. There's just a direct pipeline into our data warehouse. And then lastly, we do transformation. So as I explained to Andrew, we use dirty data to basically mine. Once we find something interesting, then we start cleaning, investigating. I think it just makes sense because of the size of these big data sets and the velocity, etc. I can't say all the F's, but it's just the data is just moving so fast and there's just so much of it that it's just impossible to keep up. So I know service and things are becoming faster. When if you think about location tracking on phones and things like that, that's quite in the news at the moment. In South Africa alone, 60 million people, but probably how many million phones and SIM cards. So if we have all that information, it's just quite a big data set. Okay. Then spatial ETL. This is now ETL that's specifically focused on geospatial data. So I saw ArcGIS has some options of it, but it seems very rudimentary actually, because I don't think ArcGIS is in the same league as your AWS type things. I don't think the data warehouse scale is exactly the same. So the other option that I saw in the spatial aspects is GeoKettle. This is an open source application. They are in the OSGeo Live disk, but their website is not working. So I also don't have a lot of confidence in them. But all your cloud services, AWS and Google, has some spatial functionality. So that's quite useful, and you can actually then do all these spatial transformations with them as well. So common ones that is listed, reprojection. So that makes sense. I think all of you have had this problem where you have data in 4326, WS84, but then there's UTM, etc., and just getting everything in the same projection. Filtering your data out, only using things with coordinates, for example, spatial transformations, topology, fixing the topology, adding topology if it's not even there, resymbolization, and geocoding. I think geocoding is probably one of the most popular ones, and yeah, and it's probably also one of the more difficult ones because you need a lot of extra things to actually do geocoding quite well. So that's the ETL. So it's very let me just stop sharing another. It's very rudimentary. I told you now, but it's just a basic introduction. So the idea is then now to go and explore a little bit of this with the Amazon Web Services practical or assignment, just so that you get an idea. Unfortunately, 1 week of this is not really going to make anyone a data engineer. But once you've signed up for the AWS education, you get access to the AWS Educate platform. And there they actually have a bunch of free courses. So there's a professional development category. And in there, there's things such as a data integration specialist and things like that, where you can actually earn a virtual certificate that you can add to your CV.